me. So what we did in 6-1 was actually kind of difficult stuff, especially the very first time you see it. I know I did a great job of explaining it, but we need to use it a couple of times before we really get it. But that's going to come in section probably 6-4. Section 6-2 and 6-3, which we're going to start today, and if we don't finish, we'll finish on Monday, comes along the lines of solving trig equations. So we're going to take algebra concepts, and we're going to take what we learned in trig to be able to be given an equation and come up with a solution. Now, I'm taking a look at this, and I'm seeing 2 sine of theta minus 1. And generally, when we're working with looking for an angle measure, and this should always help, it should be like a theta or an alpha. And if I'm looking for a number, it should be more or less like an X. But the author is inconsistent. I sometimes get inconsistent. But in order to solve this, it's beside the sine. So I know it's going to be an angle measure. Sometimes you're going to be asked to solve it between 0 and 360 degrees. Sometimes you're going to be asked to solve it in radians. But you should be able to do the quick conversion. And like me, you probably prefer to work in degrees. So let's take a look at this guy. And I want to solve for theta. And, okay, if this was just an X in there, so a lot of times just think of that as an X, I'd have 2x minus 1, and I'm going, well, I know how to solve for X. I'd add 1 and divide by 2, and I would have something along the sine of theta equals 1/2. The sine of theta equals 1/2. And now I'm going to go, okay, first question, how many answers are there?
Four.
4?
No.
No.
2.
2. Yeah, there's 2, right? I'm thinking about where is my hairbrush? Where's all spiders? We're back to, some of these building blocks we learned as we've gone through the semester. And I need to keep reusing them over and over and over. And now, okay, so the sine of theta equals 1/2. So this could be a theta, and this could be a theta. And now I'm saying, okay, the sine is opposite over hypotenuse, and by location, that works good. And wait a minute, what am I talking about? There's the hypotenuse. That's the adjacent. What adjacent works there? Oh, look at that. Square root of 3. I know my answers. Theta equals, what triangle is this? 1 square root of 3, 2.
You're 60-30.
Yeah, it's a 30, 60, 90. So if I'm looking at this theta across from the 1, that would be the 30 degrees. And when I go out here into the second quadrant, I'm using a reference angle of 30. Again, reference angle of 30. So my second solution would be
150.
150. Very good. 2 answers. Hopefully you're going like, okay, I think I can do these. Not so bad. Let's take a look at another one. Then I'm going to cut you loose on a couple, see what y'all can do. Sine of x, tangent of x equals the sine of x. Sine of x, tangent of x equals sine of x. When I started this earlier, I said, don't forget your algebra concepts. Don't forget your algebra concepts. And part of what I mean by that is, if I was just simplifying, I would cancel that. If I said this though, x squared equals x, and bad example. Don't look at that one. Don't look at that one. It's gone. Magic eraser. So yeah, I'm missing what I want to say there, so I apologize if I'm causing any confusion. One of the things I might want to do here is divide by the sine. And if I did, I would be left with tangent of x equals 1. Then I'd go through and figure out where does the tangent of x equal 1. Again, these should be theta, but the author does x, and I don't know why. Still an unknown. So if I did that, the tangent of x equals 1, I'm going to say, okay, I have a couple of ways of figuring out when the tangent equals 1. That would be sine over cosine, right? The tangent is sine over cosine. Okay, here goes this triangle. 1 over 1. That should look familiar. What is that? 1 square root of 2?
4590.
Yeah, that's the 45. So I know one of my answers is 45. All spiders taste. Now I'm over here in the third quadrant. What would my second answer be? If I come over to the third quadrant and take a look at it there.
225.
Yep, 225. Great. And I'm going, woohoo, I found 2 answers. It's a 5-point question, and I only got 3 out of 5. That's because I lost an answer. And here's why. Let's take a look at what's going on over here on the left. What if I did one of my algebra concepts and said, you know what? I'd like to not delete any answers, but I'm going to do this. Subtract sine of x from both sides. And all of a sudden I'm thinking, wait, there's a 0. If I could write this as a product, that would be awesome. And I can, because I can factor out the sine of x. I now have tangent of x minus 1 times sine of x. And the 0 product property from algebra says either this is equal to 0 or that is equal to 0. So now I have sine of x equals 0, and I have the tangent of x minus 1 equals 0. And I'm going, oh yeah, I already found those 2 answers. Cool. I found those 2 answers, 45 and 225. But here comes 2 more answers. When is the sine 0? And hopefully you're somewhere along the lines of when is the sine 0? I got 2 different ways I could do this. One, I can look at the unit circle. Oh, that's very round. No. And I know everything in the unit circle comes in ordered pairs, cosine and sine. So this is the point 1, 0. And I'm going, oh, 0 degrees. That's right. And this was the point 0, 1. This is the point -1, 0. So there's the other one, which would be 180 degrees. That's one way folks like to find those, by thinking of the unit circle whenever I'm dealing with 0s and 1s and stuff. The other way is, well, heck, what if I think about the sine graph? When is it 0? At 0 degrees and at 180 degrees. So I had 2 different ways that I come up with it. I usually do the graph because I go scratch, and then go, hey, when is the sine equal to 0? Here at 0 degrees and here at 180 degrees. 4 answers. 4 answers. So what do you think? Not too bad? Good. Good. The comments are flying in. Yeah, that's not too bad. Sergio, are you here yet? Ethan likes it. That's good. All right, so I'm going to put a couple of more on a piece of paper, and I'm going to put you in some groups and let y'all talk about it and see if you can come up with them. I should write them here. So first one's going to be the tangent squared of x plus the tangent of x minus 2. The second one, cotangent of x times cotangent of x plus 3 equals 1. And then finally, the last one of the three I'm going to have you work on. And don't start crying. Okay, first one, tangent squared x plus tangent of x minus 2 equals 0. Boom. Second one, cotangent x times cotangent x plus 3 equals 1. Boom. The third one, tangent of x plus square root of 3 equals secant x.
I have a question. So like, how do you know where to draw the triangles?
Like over here. Okay, so in this first one, I know my sign is positive. So I go back to that all spiders taste crunchy, and the two quadrants where the sign is positive is the first and second. If I come down here, the tangent equals positive, all spiders taste crunchy. It's going to be the first and the third. Okay, so it's going to depend on what's the sign here. Tangent of x equals 1, positive in the first and third quadrants.
So if it was like negative tan x, then it would be like in the second quadrant then?
Second and the fourth.
All right.
Yep, yep. Yeah, that's one, that's reusing one of those building blocks from way back about location and using reference angles. Okay, tangent squared, actually, we got that one, we got that one, and we got that one. So I'm not going to put you in loner groups. I'm going to put you in groups of at least 3 so that we can get some discussion going. Hopefully there isn't any dictators, aren't any freeloaders, but I'm going to go with 4 groups. And I'm going to give you a little bit of time. I'm going to go take a look at that quiz while you're working on these, and then I'll bring you back and see what we came up with. All right, questions? All right, I'll see you in a little bit.
On my end,
Yeah,
it's still
let's see what we have. I see, oh, I almost see x squared and x, and so, yep, this guy's going to factor. I'm going to get tangent of x plus 2, tangent of x minus 1. And hopefully a bunch of you saw that and you were able to factor it. Feeling pretty good about that. I have things like tangent of x plus 2 equals 0, tangent of x minus 1 equals 0. Oh, I can run with this one. Tangent of x equals 1. And when does the tangent equal 1? Yeah, buddy. I already drew that one. Nice. At 45 and 225. So at 45 degrees and 225 degrees. Okay, just like traditional factoring. I separated all of that. Now, the tangent of x plus 2 equals 0. I'm going to go with the tangent of x equals negative 2. And I'm kind of stuck here. Now I know my tangent graph. First of all spiders taste crunchy. It looks like it would be negative in the second and fourth quadrants kind of deal. And if I think of my actual tangent graph, I have something that looks like that. And the tangent of what angle measure is going to give me negative 2? Any thoughts on this? When would the tangent be negative 2? Well, I think I'm going to have to grab my calculator. I don't know of any of my special triangles that would give this to me. You know, I start thinking of the ratio of -2/1, and I have my 30, 60, 90 and my 45, 45, 90, and none of those work. So X is going to equal the inverse tangent of -2. I'm going to do this in terms of degrees. Ooh, on. I want to make sure my mode is degrees. I'm happy with that. So I quit. And now I want to hit second tan to get the inverse of, down below the 3 is the -2, and I hit enter. And I see a number that looks like -63.435, -63.435 degrees, -63.435 degrees. All right, well, I'm hanging on to that bad boy because that's going to help me up here. That does in fact put me in this quadrant. So if I wanted to find the angle measure in this quadrant, what is -63 degrees? I'm going to do 360, boom, minus 63.435, and I get 296. 296.565 degrees. And that's my answer over here in the fourth quadrant. Want to find an answer in the second quadrant? I'm going to do 180 minus 63.435 degrees. 116.565. So again, I had to use something else that I haven't done yet to find these two answers. Well, I have done it. I plugged them into the calculator, but I'm using the inverse tan to find it. Okay, so here I'm using the inverse tan to find the answer for this, because this has two answers. And I'm saying that clearly because to Monday we'll be doing something else along those lines. But when I start with this, I have two answers. When I got to here, I only had one answer, but I had to remember I was looking for two. So yeah, boom, hard. Don't know if anybody got it. If you did, fantastic. Okay. Anybody get this next one started?
So we don't have to make any right side equals 0. We don't have to make it.
I think so. I think that's what I would do. I would make this the cotangent squared of x plus 3 cotangent of x minus 1 equals 0. Okay, yeah, that looks hard. The cotangent sines and oh geez, and anybody have an idea? Well, what did we do up here? We factored, right? Can I do my traditional factoring? I don't think so. So what am I going to do? Here's what I'm going to do. I'm going to say, let's let W equal the cotangent of X. So right now, W equals the cotangent of X. I have W squared plus 3W minus 1 equals 0. And if I look at it that way, and I'm going to say, okay, yeah, oh boy, W equals negative B plus or minus the square root of B squared minus 4 times A times C, which becomes plus 4. Oh my goodness, all over 2A. Really? Yep. Negative 3 plus or minus the square root of 13 over 2. And I'm going to go back to my calculator. Oh boy. Negative 3 plus the square root. The square root. So I'm doing negative 3 plus the square root of 13. And I need my arrow to get out of that square root. I'm gonna hit enter, and now I'm gonna divide that by 2.303. So one answer is 0.303. Still with me? -3, this time minus the square root of 13. Get out of there. Divide that by 2. I get -3.302. Nuh-uh. 3 plus square root of 13. That's the nice thing about these calculators. -3 plus the square root of 13. Square root of 13. Okay. -3 is negative. Oh, yeah, there. Okay. So this time it's -3.303. -3.303. All right. So I got, oh boy. So this is W still. So now I'm going to switch it. I'm going to say the cotangent of X equals 0.303 and -3.303. Well, crap, I thought these would be a lot easier. This one's not so easy. What do I know about the cotangent and the tangent? If I flip this, I have to flip this. And I could write that out if you really wanted, but that's what we can do. So I'm going to make this become tangent of X equals 1 over 0.303, and it equals 1 over -3.303. Oh my goodness. Tangent of X equals, calculator, give me some help. On 1 divided by 0.303. Now that's times 1 divided by 0.303. How did that? 3.3. And 1 divided by -3.303 equals -0.303. All right. So I have that. I have the tangent equaling 2 different numbers. And guess what? I'm going to end up with 4 answers again. Okay. How am I going to do that? Well, as I've checked before, just a few moments ago, the tangent, all spiders taste crunchy. It's positive in the first and third quadrants. It's negative in the second and fourth. So the first thing, X equals the inverse tangent of 3.3. Then my second one is going to be X equals the inverse tangent of 0.303. Goodness gracious. Don't put one of these bad boys on the quiz. It'll take forever. All right, I already know them in that. So let's see. I want the inverse tangent of 3.3. That's going to be 73.142 degrees. Found one answer. I know it's also positive in the third quadrant. So I'm going to take that 73 and I'm going to add 180. 153.142 degrees. There's 2 of my answers. Now I want the inverse tan of 0.303. And that's giving me, it's a negative. My bad. That's a negative in there. Let me do that again. The inverse tangent of negative 0.303. I get -16 degrees. So I'm going to go 360 minus that. And I know I'm going quick. And when I'm done, I'll take questions. So this is 343.144 degrees. That's my fourth quadrant answer. And my second quadrant answer is going to be 180 minus that. So I'm just going to hit -180. And that should get me in the second quadrant. Yeah, these bad boys look innocent, but they put a whole lot of stuff we've done together.
Wow.
I like it. Okay, it's positive in the first and third quadrants. So when I found my first quadrant answer, I added 180 to it. And dumb me doesn't know how to add 180. 253. My second one was a negative degree measure, which puts me in the fourth quadrant. I subtracted it from 360. And then in order to get from the fourth all the way back to the second, I subtracted 180. Questions? All right, let's try another one. Tangent of x plus the square root of 3 equals the secant of x. Tangent of x plus the square root of 3 equals the secant of x. Any ideas? Think on that for a couple of seconds. The tangent of x, I'm thinking, well, I wonder if I need to get them all on the same side again. Wonder if I need to get them all on the same side. That would be one thing. Another trick of the trade. Another trick of the trade. I see that I have tangents and I see that I have secants. And one of those could be like getting a common denominator. This is sine over cosine. This is 1 over the cosine. And I could multiply everything by the cosine. And I don't know if that would help. So another trick of the trade is I'd love to make this all in terms of one trig function. And I'm gonna do a cheater. This is one of those where once you see it, you're going, okay, I'm going to square both sides. And I'll tell you why. Down here, I now get the secant squared of x. And I know that the secant squared of x is the same as sine squared plus cosine squared equals 1. I need my little cheater here. If I divide by the cosine, sine divided by cosine is tangent squared. If I divide this by cosine, it's 1, right? I'm dividing by cosine squared, and this becomes secant squared. Nice. I can change secant squared and replace that with tangent squared plus 1. Nice. Now I have to take care of this side. This is a binomial, and I'm going to square it. That's like multiplying it by itself. Double distribute. Tangent squared of x. I have square root of 3 plus square root of 3 is 2 square root of 3 tangent of x. And then when I square that, I get plus 3. Everyone okay with that? Lots of algebra skills coming back. Now, instead of our unknown being just an x or a y, it's a trig function. Okay, so now I have, check this out, Funk Soul Brothers. I'm going to subtract the tangent squared from both sides. Boom. I'm left with 2 square root of 3 tangent of x. I'm going to subtract the 1 from both sides, plus 2. I like it. I love it. Algebra. Subtract 2. Divide by 2 square root of 3. The 2's are gone. tangent of x equals -1 over the square root of 3. And I'm going, oh, wait a minute. Hold on, Bubbaloo. All spiders taste crunchy, right? All spiders taste crunch. I have answers in the first quadrant and the fourth quadrant. Excuse me, second and fourth. I come over here to the second quadrant and I go, opposite over adjacent. There it is. Whoop, there it is. Whoop, there it is. X equals, that angle measure right there is my 30, 60, 90 triangle. If the reference angle is 30, that's for 150 degrees. My other answer is going to be over here in the fourth quadrant. It's going to be that 30 again. If I subtract it from 360 or add 180, I get 330 degrees. You are my sunshine, my only sunshine. What do you think about that? Now, all of these problems that I just did are the problems right out of section 6.2. So if you are stuck and you don't get the video and you want to go and look it up and try to get a little bit more flavor out of it or something, you can. Go to the book and see how they're all written out. Section 6.3. More equations. Sine. Now let's see what we can do with one or two of these. Ba-da-ba-ba-ba. All right. 2 sine of it. Oh, okay. So we're no longer working like we just did in 6.2, where all of these were just sine of theta, sine of x, tangent of x. We're now going to bring into play some things like the half angle and work with it, not to try to be confused or anything, but the same thing. We're solving trig equations. But we're applying more and more things that we've learned. Okay. The sine of x over 2 equals 1/2. We agree to that, right? And what I'm now going to do is I'm going to let theta equal x over 2. And you'll see why in a minute. Again, this is one of those that once you do it once or twice, you pick up the pattern. So now the sine of theta equals 1/2. And if I get ready and I draw a triangle, the sine is 1/2. Oh, there's going to be 2 answers, all spiders. So it's going to be 2 answers. Let's see, sine is opposite over hypotenuse squared. I know what that is, right? So right now I just solved this and found theta equals, this is my 30, 60, 90. So that's 30 degrees. When I put it over in the second quadrant, it's 150 degrees. Okay, cool. Going to plug back in. X over 2 equals 30 degrees and 150 degrees. Not too bad, because if I want to solve for x, I'm going to multiply both of these by 2. X equals 60 degrees. X equals 300 degrees. Oh, isn't that clever? Yeah. Can we do another one so that we have less to do on Monday? Sure. Because what we're doing today is going to also help you with that assignment number 3, because it's a lot of problems like this, solving these trig functions. So the more we do today, the more it's going to help you with being able to work on that assignment 3 over the weekend. How about this one? Cosine of 2x equals cosine of x. Let's see, up in this last fella, I only had one trig function. And, yeah, it was the inside the parentheses, it was x over 2. But here I have different ones. I have 2x and I have x. So I can't do like theta equals 2x because then I'd have theta over 2 and it would, so this was great that I learned it up here, but I now need to, somebody sees it. What should my next line look like?
You the double angle.
Yeah, use one of my cosine double angles. And is there one that looks exceptionally pretty? Pick one that you'd like to use. Well, there's 3 of them. 2 of them I think work pretty well. Anybody?
I'm sorry, what was your question?
What? So I'm going to replace the cosine of 2x with something so that I'm working with just x's that would be inside these parentheses. I have 3 identities. Charles said, we're going to replace this with an identity. Which one would you like to use?
Transfer to 2 cosine square x minus 1.
2 cosine squared of x minus 1. I like it. Now all of a sudden I'm seeing kind of like the quadratic again. I'm going to go 2 cosine squared of x minus cosine of x minus 1 equals 0. Oh, I like it.
Yeah, I see.
Yeah. Yeah, that's good. Take a second or two, work on that, see what you can do. Yeah, I'm giving you the fishing rod. You need to fish a little. You'll know when the fish is biting. Do-do-do-do.
So we factor.
Yep. All right, see you, Patrick. I think this is going to factor into 2 cosine of x, cosine of x. Yeah. I need a -1 in the middle. And I believe this is going to be +1 and -1. All right. Cosine of x equals -1/2. Cosine of x equals 1. Set each of these terms equal to 0, solve, and I get those kind of ideas. Cosine equals 1, I can do that. Yes, sir. Cosine equals 1 when x is 0 degrees. Only time it equals 1. 360 is when I start to repeat, and that's the same as 0. So I only have one answer for that. Yeah, Gianni.
So, you know how you said that like you can't make 2x into theta?
Yes.
Wouldn't the cosine turn into 1 though? Technically, because it would be. You
So
can't have the, oh,
if I made this theta, then this side would have to be theta over 2.
oh, okay, I see now.
Yeah.
Yeah, I see what you're saying. All right, thank you.
Yeah, it's a good question. It's a good question. Oh, these 2, when is the cosine negative? All spiders taste crunch. In the second and third quadrants. Somebody get an answer for x? There's 2 of them.
120.
120. And what about over here in the fourth quadrant?
240.
How about 300? If
No,
this
no.
if this is 60. Okay, because you went -1, square root of 3 and 2. If this is 60, I would go 60 less than 360, which is 300. Again, or I could have just advanced 180. Whew. What do you think? One more? One more? Kelsey, what do you think? Kelsey, give me a thumbs up if you want one more. Oh, Ethan says one more. All right, good. Again, this is gonna help you working this weekend on assignment 3. Hopefully you're working on assignment 3. What if I gave you this bad boy? 4 sine theta cosine theta equals square root of 3. I like that my Wi-Fi didn't drop today. I shouldn't have said anything yet. What do you think about that one? None of these are, neither one of these is squared. Neither one of these is a 2 or blah, blah, blah. I could bring that over and it equals 0, but I couldn't factor. I can't divide by 4. Well, I can, but I don't think that's doing me any good. But I keep looking at this sine and cosine. Keep looking at sine and cosine.
Divide cosine for all of them.
No, not yet. Not yet, because then I have a cosine down there and yeah, it's a good idea, but I'm looking at the next step or two after that and yeah,
Would you square both sides?
I could. That would be a 3, that would be a 16. I have sine squared and cosine squared. And then I could maybe take one of those and put it all in terms of sine squared. It's an idea. 16 sine squared of theta cosine squared of theta equals 3. But I'm going to send that 16 over. And I'm going to make the cosine 1 minus sine squared. All right, good idea. Because I got rid of, oh boy. I did get rid of one of them. I got it all, I have it all in terms of sine. I could distribute, I'd have sine to the 4th. Oh boy, negative sine to the 4th of theta plus the sine squared of theta minus 3 over 16 equals 0. Oh, the quadratic formula comes into play and oh boy. Great idea. Partial credit. I probably would give you 3 out of 5 if you were working with it. This really looks like something on my identity sheet. Is there something on the identity sheet that this really, really looks like? It really, really, really almost looks like this is a little wompy. What would it be great if that number was?
It was a 2, the
It was-
double angle formula.
You got it. What if I divide both sides by 2? I get 2 sine of theta cosine of theta equals square root of 3 over 2. Ah, I can use an identity to change this left side. Great idea, whoever had that idea. Is that you, Sergio?
No, sadly, it wasn't me.
Was it Chuk?
Yeah.
It was Thomas.
Thomas. All right, thanks, Thomas. Thanks. So
Yeah,
now
so-
what can I replace this with? This is the same as the sine of 2 theta. Yeah. Thanks, Kelsey. Kelsey, did you just bark? No, that's okay. All right, so I'm gonna go, ooh, I know a trick from before. I'm gonna let W equal 2 theta. So now I have the sine of W equals the square root of 3 over 2. Ah, yes. It's all spiders. So I'm gonna go and draw this. Sine is opposite. Square root of 3 over 2 and 1. And it's gonna be over here as well. That's gonna be my 60-degree angle. So W equals 60 degrees and 120 degrees. You're gonna like this the way it ends. You're gonna like it. Maybe. Now I'm gonna put 2 theta back. And I'm gonna divide by 2. Theta equals 30 degrees and 60 degrees. But in the words of the immortal Meatloaf, stop right there. Because there's actually gonna be more answers. If I have 60, good. If I have 120, great. If I went around again and I added 360 to this 60, what would I get? 360 plus 60,
420.
420. And guess what happens when I divide that 420 by 2? I'm still in my range of 0 to 360 degrees, which is what I always have to find my answers. So whenever I see like a 2 here, I know I want to go around twice. So 60, if I add 360 to it, I get 420. 120, if I add 360 to it, I get 480. When I divide that by 2, I am still in my range from 0 to 360 degrees. Wow. Yeah, it's good we covered this one to help with that assignment. That's a whole lot of stuff we put together. This was a great idea to get me started. And again, it's how did you know how to do this? Well, I've done them before. I know a lot of the tricks that you would need to solve it. And now you're in a situation where in order to be able to do well with these, you need to practice them and practice them and practice them.